Assalamu alaikum students. Today we will discuss about Young's modulus. That what is Young's modulus? Okay, it is the topic of chapter number 7 of physics of ninth physics. So in our today's topic we will discuss its definition, a review of stress strain, my previous lecture. Okay, so explanation of Young's modulus and formula and unit of the Young's modulus. So first of all, we will discuss about what is Young's modulus. Basically, we will take the concept of Young's modulus. So Young's modulus is basically the measurement of the ability of material. Like I have already discussed in my last lecture, materials like iron, like steel, okay, aluminium or plastic. That the Young's modulus is the measure of the ability of the material to withstand the change in length. So if we talk about the length, so we will discuss that the how much change is considered here. So change in length, we are talking about the length. So Young's modulus is basically the measure of the ability of material to withstand the change in length. Young's modulus जो है ये उस मटेरियल की एबिलिटी है, उसकी सलाहियत है कि उसमें कितना चेंज आया है, उसमें उसकी लेंथ में जितना चेंज आया, मतलब उसकी बर्दाश्त करने की सलाहियत, ठीक है, कि वो कितना विदस्टैंड कर सकती है। यानी इसमें वो सारी बातें आ जाती हैं जो हमने पिछले अपने लेक्चर में डिस्कस की। यानी आप कह सकते हैं वो जो इलास्टिक लिमिट, स्ट्रेस, स्ट्रेन, हम आगे डिस्कस करेंगे इसको साथ साथ। तो सो यंग्स मॉडुलस इज़ द मेजर ऑफ द एबिलिटी ऑफ मटेरियल टू विदस्टैंड चेंज इन लेंथ। सो लेट्स मूव towards the first point. What is the definition of Young's modulus? Young's modulus is basically the ratio of stress and strain. So stress that we have discussed, okay, in our previous lecture, stress is the force per unit area. The ratio of stress to the tensile strain, here we are talking about the length, deformation in length. So strain is the deformation, tensile deformation in a length, okay. A tensile strain is called Young's modulus. Here we have the symbol of Young's modulus. It can be represented by y is equal to the stress over tensile strain, so stress is the force per unit area and tensile strain is the deformation in length, okay. So let's take the review of stress strain, because it is very necessary to understand the concept of stress and strain while we are discussing the concept of Young's modulus, okay. So Young's modulus is basically the combination or the ratio of stress and strain. So we will discuss about stress, that what is stress. Stress is the force per unit area. So if you apply stress on something, like we were talking about the mass spring system in our last lecture. So when you apply stress on them, then you had seen that there were some kind of deformation in that spring, okay. So here we have stress, force per unit area. Its unit is Newton per meter square, as we have already discussed in last lecture. What is strain? Strain is basically the change in length per unit length. That if you have a length of a rod or length of a spring that is 5 centimeter or 5 meter, okay, when you apply stress on them, if you stretch or you compress the spring, then you will feel or you will observe that the length of the spring will change, okay. And that stress which have changed the length will produce in it the deformation, okay. That deformation will be the strain. The strain will be change in length per unit length is the original length, and change in length is the change which you have observed in that spring, okay. It doesn't have any unit, so no unit. Stress does not contain any unit, okay. So no unit, because the change in length is also in meters and the total length is also in meters, so meter cancel out and there will be no unit, okay. So let's move towards the third point, explanation of Young's modulus. What is Young's modulus? How can we find it? So by understanding the concept of Young's modulus, uh, as we have discussed in our definition, it is the ratio of stress and tensile strain. So here we have a little explanation about that. That suppose you have spring, okay, spring or wire or a metal rod. By applying stress or stretching it, the length changes, like we will discuss here. So if you have a mass that is attached to a spring, okay, and when you will stretch the mass, you can see that it is the total original length of this spring, that is represented by LO, okay, that is represented by LO. And when you will stretch the spring, so here you will observe this one here you will observe this is the change, basically change. That what change have you observed in it by stretching the spring, okay? So the length will be observed by you, it will be L. From L naught or original length to change it, it is changed in L, okay? So what is the change? The change is delta L. So we will discuss here by applying the stretch or stress on a spring or a rod or some kind of wire. We will observe that the length change. We will observe the length changes. Okay, delta L is equal to L minus L naught. So delta L is the change. L is the length after stretching. L naught is the length before stretching. It means original length, okay? So you will find it by subtracting it from the last value, first value from the last value, okay? It is the last, it is the first one. So you will observe the change delta L. So let's move towards our first last point, that the fourth point, formula and unit, that how can we made it. So fourth point will be our y is equal to stress over tensile strain, that we have already made here the formula. Y is equal to stress over strain, tensile strain, okay? Stress, what is the stress? Stress that we have discussed here, stress is the force per unit area. Put the value of stress here, force per unit area, so divided by I'm representing the division sign like this, okay? It will be easy for you to understand that how we will make this formula, okay? How we will derive this formula. So stress and strain, tensile strain is the stress, force per unit area, divided by tensile strain, delta L over LO, L naught, okay, original length. So it is the tensile strain. As you know that when you solve this expression, the division sign will change into multiplication, okay? So after changing in multiplication, this side will change, will also be changed. How? The denominator will be go to upward and the numerator will be downward, okay? It is the rule. You have studied it, I think so, you have studied it in the math. So here we know that the numerators are multiplying together and the denominators are multiplying together. So F multiplied by L, so you can write it L naught here, so removing it, okay, and A multiplied by delta L. It is our final expression, that will be y is equal to, yani Young's modulus is equal to FL naught over A delta L, okay? Now we will discuss its unit. What is the unit of the Young's modulus? Because we know that the tensile strain have no unit, it has no unit, okay? So only force per unit area, it means stress has unit. So as we know that the unit of force per unit area is Newton per meter square, which is the unit of stress. So same is the unit is will be the Young's modulus. So the unit of the Young's modulus will be Newton per meter square. If you will find out, if you want to find out with the formula, from the formula, so force will be the Newton, length in meters, delta length in also meters, and area in meter squares. This meter will cancel out this meter, so force, this meter square will go upward and becomes the meter per meter square, so it will become Newton per meter square. It is our it is the unit of the Young's modulus. So it is our lecture, and let me explain it, revise it, okay, in simple way. तो हमने आज फिर क्या सीखा है, आज हमने यंग्स मॉडुलस के बारे में सीखा, उसकी पहले डेफिनेशन को डिस्कस किया, स्ट्रेस स्ट्रेन को डिस्कस किया, रिव्यू लिया उसका, एक्सप्लेनेशन यंग्स मॉडुलस की, फार्मूला और यूनिट उसका देखा। सबसे पहले डेफिनेशन में हमने ये देखा कि स्ट्रेस स्ट्रेन है जो डेफिनेशन में हमने देखा कि यंग्स मॉडुलस बनता कैसे। यंग्स मॉडुलस बेसिकली दोनों रेशियोज़ का कम्बिनेशन है, यानी स्ट्रेस ओवर टेंसाइल स्ट्रेन, इसे कहते हैं यंग्स मॉडुलस। द रेशियो ऑफ द स्ट्रेस टू टेंसाइल स्ट्रेन इज कॉल्ड यंग्स मॉडुलस। यंग्स मॉडुलस के बारे में बेसिकली यहाँ पे मैं एक्सप्लेन कर चुका हूँ कि ये बेसिकली क्या है, ये मैयर है, मैयर ऑफ एबिलिटी ऑफ मटेरियल टू विदस्टैंड चेंज इन लेंथ, ठीक है, लेक्चर के शुरू में आप देख सकते हैं उसे। सो स्ट्रेस फिर हमने आगे देखा था रिव्यूज़ का लिए, स्ट्रेस का स्ट्रेस क्या था, फोर्स पर यूनिट एरिया, उसके यूनिट को डिस्कस किया। स्ट्रेन, स्ट्रेन क्या था, चेंज इन लेंथ पर यूनिट लेंथ, उसको डिस्कस किया, ठीक है। स्ट्रेन को देखा कि स्ट्रेन को मेजर कैसे करते हैं, नो यूनिट, इसका कोई यूनिट नहीं होता। तो फिर तीसरे नंबर पे हमने डिस्कस किया था एक्सप्लेनेशन यंग्स मॉडुलस की, कि इसको किस तरह बनाते कैसे हैं, एक्सप्लेन कैसे करते हैं। बेसिकली हमने यहाँ पे एक स्प्रिंग की बात की थी, ठीक है, तो स्प्रिंग के साथ हमने मैस को अटैच किया हुआ था। उस स्प्रिंग में जिसमें हमने मैस को अटैच किया हुआ था, वहाँ पे लेंथ और चेंज इन लेंथ की बात की हमने, ठीक है, जब हम उस पर स्ट्रेच अप्लाई किया था। फिर हमने चेंज इन लेंथ को लिया था L माइनस एल नॉट, और यहाँ पे फोर्थ वन हमारे पास आ गया था जो पॉइंट हमने यहाँ पे लिया था फार्मूला यूनिट उसका बनाना है। फार्मूला यूनिट बनाने के लिए स्ट्रेस स्ट्रेन की रेशो को उसी फार्मूले को यूज़ किया जो हमने उसकी डेफिनेशन में यूज़ किया था। फिर हमने स्ट्रेस का फार्मूला अप्लाई किया, उसके बाद इसका फार्मूला अप्लाई किया, स्ट्रेन का फार्मूला अप्लाई किया। देन हमने देखा कि इस डिवीजन को चेंज किया, डिवीजन को चेंज करने से ये वाला भी चेंज हो गया, ठीक है, नोमिनेटर डिनोमिनेटर में और डिनोमिनेटर में आ गया। सो हमने ऊपर वालों को आपस में मल्टीप्लाई कर दिया, नोमिनेटर्स को डिनोमिनेटर्स को आपस में मल्टीप्लाई कर दिया। तो यंग्स मॉडुलस के लिए ये वाला फार्मूला हमने जनरेट कर लिया, इससे हमने ये वाला यूनिट निकाल लिया। ओके, अल्लाह हाफिज़।